So today I'm just kind of going to go through these first 20 slides. It might be a bit of a brief overview. So a loop is when you have a chunk of code that you want to run more than once. So if you want the piece of code to repeat, you would put it in a loop. And there's several different kinds of loops because you can make the code repeat in different ways. So the two we're going to talk about today are we're going to talk about the while loop and the for loop. And those are two pretty common and pretty basic ones. The while loop is going to use the reserved word while. So you'll type it just like that and it'll change colors because it's a reserved word. And then we're going to have the condition. So that's going to look very similar to the if statements that we saw earlier this week, right? We're going to say, while this certain condition is true, then I want you to do all of these things. So over and over again, as long as this condition is true, I want you to repeat and execute all of these instructions. That syntax looks very similar to the if statement that we saw before. Okay. So it's going to take a look at that condition. It's going to evaluate it. And if it is true, it will run all of the lines of code that are indented over. That's how you can show that something is part of the loop. It will be indented over. And then if the condition is false, then we just break out of the loop entirely. It'll skip over everything that has been indented and it'll go down to like the next line of code after where the body of the loop ends. Just sort of some vocabulary here. Every iteration of a loop is like each time that it runs. So if you do the same thing 5 times in a row, every individual time that you did it would be an iteration of those actions, an iteration of our loop. This is called a flow chart. A flow chart is a nice way to graphically represent and visually represent what our program is doing. You start here at the top and you kind of follow the arrows down. So it says flow of control is going to come into the loop, check the conditional. If the conditional is true, run all of the code that's part of the loop. Go ahead and run all of those statements and then go back to the top of the loop, because you need to check the conditional again. If the conditional is still true, it's going to run through the statements a second time, go back and check the conditional, and it'll keep doing that continuously until finally something makes the conditional be false. And then once it's false, it will break out entirely, skip over all of the statements and go down to the next line of code. Here is an example, a piece of code. So here we had a variable called X, and that's going to be our loop control variable because it is what I am using to determine how many times my loop is going to run, right? How many iterations I'm going to make, because somehow I have to eventually have a way to make the condition become false. Otherwise, I'll make an infinite loop. It'll just go on forever. So you have to have some sort of condition that can be true a few times and then will eventually stop and become false. So in this example, we started with X equals 1, and we say, as long as X is less than or equal to 5. Well, that is true right now. 1 is less than 5, so this condition is true. We'll come down here, we'll run the body of our loop, and the body of our loop says to print out the number and then add 1, right? We can add 1 to it. And we could have used one of those combined assignment operators that we saw yesterday here. We could have said X plus equals 1. I mean, either way, if you do it shorthand or write it out, that's fine. So then when I come back up here the second time, now X equals 2. And it's going to check the conditional again. Is 2 less than or equal than 5? Yes, print it, add it. 3, yes, print it, add it. 4, yes, print it, add it. 5 is equal to 5. So we're still true. we will print out the 5. Here, when we add 1 and make the number 6, when I come back and check the conditional that time, 6 is not less than or equal to 5. Finally, my condition is false. I break out of the loop. I would move on to the next line of code and execute from there. So I printed out the numbers 1, 2, 3, 4, 5. We did not print out the 6, right? Because as soon as the X became 6, right down here, I came back up and checked the conditional again. It was false. We broke out. We never looked into that loop again. So we never ran that line that said to print it. So something has to eventually allow the loop to become false so you can exit. Otherwise, you're going to accidentally create an infinite loop. And that can happen. That is a real possibility. You can accidentally make a loop that would just run forever until something would have to shut your program off, okay? And what could happen if there is not a way to shut your program off is like, so for example, if the user who doesn't have access to the code tried running it and it would just ran forever and there was no way to shut it down, it would eventually overrun your runtime stack. You'd use up all of your memory on your device and then it would shut off. The operating system would shut it off. So an example of an infinite loop. So in our previous example, we started at 1, we were moving towards 5, we added 1 each time. We got closer to exiting the loop. We were at 1, 2, 3, 4, 5. We were approaching the case where we would break out of our loop. What would happen if instead we did not add 1 or we subtracted 1, right? If I started at 1 and I subtracted 1, I'm always going to be less than or equal to 5. I accidentally would have made an infinite loop. So here we have, oh yes, a common error. Be mindful of this. Do not use a single equal sign when you are trying to check for equality. Remember that a single equal sign is the assignment operator. Double equal signs is how you check for equality. So if you say while X and you're trying to say X equals 3, but you really aren't, you were saying as long as you can assign the value of 3 into X, and the computer's going to say assign 3 to X. Yep, did it. True. And then it comes down here. You could say X equals 4. Fine. Come back up here. While, put a 3 in X. Yep, did it. True. And so it'll just run forever. So really what we needed to have right here was X equals 3. And then we would eventually exit out of the loop. Whenever you are using a while loop for input validation, what is input validation? We have done a couple of examples now where we got input from our user and we kind of just assumed that what they typed in was correct. So for example, yesterday I made that little choose your own adventure game. And I said that, you know, if their answer equaled tent, I was only able to get away with doing that because I was the only person running that program. And I know that the answer that I was looking for was tent because I'm the one that wrote it, right? But that would not have been a very good program for me to have, you know, tried to make available for other people to run because they could have typed in lots of different responses. I wasn't very clear about what response I wanted. And at no point did I check to make sure that, you know, their response was even a legal one. You know, they could have typed in all kinds of random nonsense and I just sort of accepted it and stored it. And really, that's not a good idea. There are lots of different reasons why you would want to check that what the person typed in will actually work for your program and you know that it will run and it won't cause an error. Another reason that you can have to check for like data validation for input validation is for security reasons. People are really smart, and a lot of something that that hackers realized a long time ago was that when you were entering in information on a form and it was getting stored in the database, before they really had good input validation checking, you could enter in commands, like SQL commands that would then get stored in the database. And then it was running the commands because that's what it was like saving in this input. And so that's called like SQL injection. And now, as that happened and people realized it was happening, now we have lots of safeguards against it. You can't do that anymore. But it is a good point that you do have to validate that what they entered in was actually the type of information you expected them to enter in. One, so they don't crash your program and it'll actually work. And two, because you don't want them to have entered in something that maybe was a security risk as well. So whenever you prompt them and read in their data, you could use a while loop that would check to see if the data they entered is what they were supposed to enter. And then if it was not right, make them enter it again. Keep them stuck in that while loop and say, nope, this was wrong. Here's your error message. You need to re-enter the data. And it'll go to your while loop. It'll go back and check the conditional. When they entered it the second time, is it now the right kind of information? Nope, still wrong. Stay inside your loop. Keep making them re-enter the data as many times as necessary until they finally give valid information. And then whenever it's actually correct, you can exit the loop. So here's an example of that. If I asked somebody to enter a number from 1 to 100, I could read in their input and I could cast their answer as an integer. So now I've stored that in X. So a while loop says, as long as this condition is true, I'm going to make them keep going here. So if they entered in a number that was less than 1, if I ask them for a number 1 through 100 and they type in a 0, 0 is less than 1. So that would be, true or false, true, fall into the loop, right? Or if they entered in a number that was greater than 100, if I asked for a number 1 through 100 and they typed in 273, that would be false or true, true. So I would want to tell them, nope, should be, in the range 1 to 100. Please try again. Read them their response, store it in X. We're going to keep going until they give us a number that we really asked for. Oh, and this is something that I mentioned earlier in the video. We could use those combined assignment operators that we talked about earlier. So if you were trying to increment, add 1, keep going up 1 at a time, or decrement, subtract 1, keep going down 1 at a time. If you were trying to do either one of these things for your loop control variable, you could also just write it, shorthand. Take the value that was in X, add 1, store the result back into X. Okay. And then there are 2 different really common tasks that you might want to do that we're going to go through as examples here. And it's a counter and an accumulator. So a counter is when you have created a variable and it's just going to count, like, how many items did we find? How many times did this loop run? How many instances of some certain key term did we find? There are a lot of different times where you might want to count what is happening inside of your code. How many times it ran something? How many times the user did this certain activity, whatever. Lots of different reasons that you might want to use that. So if we want to have a counter, we would need a variable. We would need some place to store our count. It can be used as your loop control variable, depending on, if your loop needs to run the same number of times as your count. You do need to initialize it. And when you initialize a variable, initial is just like start. You're just giving it a starting value. And then you can increment it, decrement it, whatever you're trying to do inside the loop or in the loop test itself. So if you were going to initialize a counter, think for a second about what starting value would make sense to store inside that variable, right? If you didn't want to change your answer or your final result, that you needed some value to start at so that you could add on top of it, what would make sense as an initial value for a counter? I'll tell you in a second if you haven't thought of it yet. So you, like we said a second ago, you could use it to control, you could let the user control the loop. So this would be kind of like a dynamic loop. You could let them enter in values, as many values as they needed to enter until they were done. And so in that case, you would let the user know to enter in as many of these items as they want. And you would also have to let them know what do they enter in to tell the loop that they're done, right? And you've probably seen that in, games before, maybe especially older games where there would be something like, press enter to continue, or press Q to quit, or, type X to quit, or something like that, where you can keep, inputting information, but then you have the ability to control how many pieces of information you want to put in and when you're done. Okay, and we'll see an example of that too. So if I say, I'm going to make a table of squares and I am going to let the user decide how many times I'm going to do it. So if I ask them how high, this loop is going to run as long as my loop control variable is less than or equal to the number of iterations that the user told me they wanted to run, right? So let's say, for example, that I said, how many times do you want this loop to run? And they said 3. So this, and num is starting at 1. So this would say, while 1 is less than or equal to 3. Yes, it is. So I would say, okay, I'm going to print out, and this is, how do you find the square of a number? You multiply it by itself, right? So this would print out 1. 1 times 1 is 1. And then here we're incrementing to the next thing. Notice how they use the combined assignment operator for it this time. So now I come up, now num equals 2. I run through the loop again. I come back up here and check my conditional. Is 2 less than or equal to 3? Yes. Do it again. I print out a 2. 2 times 2 is 4. I increment num, it becomes 3. Is 3 less than or equal to 3? Yes, it is. I would print out 3. 3 times 3 is 9. I increment num. Is 4 less than or equal to 3? No, it is not. I would break out of my loop. 2 things I want to point out here. The value that was inside of num changed every time, because here inside of the loop, I changed the value that was in num, right? Notice how these 2 things are indented over. Num is getting incremented every time. That value is changing. The value that was inside of limit is not changing, right? This was their answer that they put in and stored, and we did not change it here. So this value changed, this value did not. Number 2, because we did math with this, we had to say the answer that they read into us should be stored as an integer so that I can compare these 2 numbers mathematically. The second common task is an accumulator. So we have a counting and an accumulator. So counting is when you're literally just keeping a count of how many times something has happened. And an accumulator is when you're keeping a running total. So like If I said, to count the first 5 numbers, 1, 2, 3, 4, 5. If I said to accumulate, keep a running total of the first 5 numbers, you would say 1 plus 2 plus 3 plus 4 plus 5, right? You'd have a running total of all the numbers. So here, if you're going to do that, you don't have to call it sum, but a lot of people do because that's what it is. It's, the sum is the result of an addition problem. So, or I've seen it called total a lot of times before as well. I mean, variable names don't really matter. As long as it's kind of clear what's happening, you can call it whatever you want. This is not a reserved word, and num is not a reserved word. These are variables that the programmer decided on themselves. While is a reserved word that would have to be written just like that. And print is a reserved word that would have to be written just like that. But everything else that you see here in green could have been changed around depending on whoever was writing the code. So if we started at 0 and we wanted to add up all of the numbers from 1 through 10, then we would take the number and we would add it to our sum. And then we would just increment our counter. So here we're adding 1 to num because num is being our loop control variable. Num is going to be the numbers 1 through 10, right? And then eventually, whenever we add 1 to num and it becomes 11, 11 is not less than or equal to 10, we will fall out of our loop. However, sum is not running through the numbers 1 through 10. Sum is adding every new number to its running total. So here's the answer to the question I asked you previously. We would initialize this value at 0 because adding 0 to a number would not change the end result. So if we started at 0, and then the first time through this, we would add 1. Okay, it's got a 1. And then we increment 1 up. So now we add 2 to our running total, but it already had a 1 in it. So I'm going to add 2. My running total is 3. And then I increment num, and we come up here and we add 3. It already had a 3 in it. My running total is going to be 3 plus 3 is 6, right? And it'll keep going all the way up through 10, and including 10 because it has the or equal to. All right. We're actually almost done, I think. So our sentinel value, oh, just kidding, we still have to do for loops. A sentinel value is, a second ago I said that you could let the user determine how many iterations of the loop is going to run. And if you were going to do that, you would have to let the user know what did they type in to eventually quit. That would be your sentinel. A sentinel is a value that tells the program, we're through reading in now, you can stop. So that could be a value in a list. It could be, that you tell the user type Q to quit or something like that. It is a value that says you can stop what you're doing, no more reading and input. We have finished gathering in our information. So make sure that something to be mindful of when you're trying to pick a sentinel is don't pick a sentinel that could be a valid answer, because then how would you know if they were trying to quit or if they were trying to input that as their data? So for example, if I was trying to enter in test scores or read in test scores from an input file, if I chose the sentinel negative 999, that would not be a valid test score. That's not something that, it wouldn't accidentally confuse a real entry for my sentinel value. So here's an example of that. We could tell the user, enter in numbers to add. We didn't say how many numbers. They could enter in as many numbers as they want. They could enter in 1, 2, 57, 131. It makes no difference, as many as they want. How will we know, right? If we don't know how many times it's going to run, if we don't know how many numbers they're going to enter in, how will we know when they're finally done? Well, we can tell them to enter a 0 to quit. And in this case, 0 is going to be the sentinel value. And we have told the user when you're done entering in information, you type in a 0 and you're through. So as long as they did not enter a 0, then I want to keep reading in their number and adding it to the total. So I'll add it, I'll get a new number, still not 0, add it, get a new number, still not 0, add it. This time they did enter in a 0 because they're through, break out of the loop. Okay. Oh, and I've been doing this incorrectly. Instead of concatenating and casting it as a string, I should have been separating my variables with a comma. So I apologize for that. That's on me because I haven't used Python in so long. I'm used to concatenating things together with the plus sign in C++ and Java, but here you can see the correct way that I should have been doing it. So my apologies there. You wouldn't, because total is a number here, and then they didn't have to cast it because they just used a comma to separate out those values. So that was bad examples that I have made on the previous videos, and I apologize for that. Okay, range is going to be a reserved word that we are going to use when we know how many iterations we want our loop to run. Okay, so instead of a while loop, which is just going to run as long as the conditional is true, we can use range to say, I want you to go through a range of this number of items, this sequence of numbers. So I can give it a beginning and an ending range, or I can just give it a 0 up to the number, or I can get really fancy. I can give it a beginning and an end, and I can tell it the step, which is a step is going to be what's the difference between, like when you go to the next number, how far out did you move? So traditionally, it's just going to increment by 1. So like, for example, if I said range 2 to 5, that would be 2, 3, 4. But if I said, if I gave it a step of 5 and I said like 0 to 100 or something like that, this is going to count by 5s if I gave that as the step. And you can even give it, and if you decrement by the step, you could do that as well. So you could even like give it a negative value. So here, if we said, so here's a for loop example, and I use a for loop when I know how many times I need the loop to run. That's the big difference between for and while. You use a for loop when you know how many iterations you want it to run. So this would say we're going to start at 1, we're going to end at 6, and every time we're going to print out I. And this is important. Notice that it starts here, and then it does not include the last one. The way that I always say this to my students is I say, like, you walked to the door, you got to the door, but you did not walk through it. So you don't include that last one. You can think about it like if you took this number and you subtracted this number, that would give you the total number of iterations you ran. So 6 minus 1 is going to be 5. And if you look down here, you can see it actually did run 5 times. So that's another way to kind of remember that I don't include this one, because if I did, if I went from 1 to 6 and I included the 6, that would really be 6 iterations, right? If I said 1, 2, 3, 4, 5, 6, I would have ran 6 times, but that's not what I wanted to do. 6 minus 1 is 5. I should have ran 5 iterations. So be careful that you remember that this second number is not inclusive. Okay. And here's an example of using the step. So here, because our step is 2, we aren't counting by ones anymore. We aren't incrementing 1 at a time. Now we are incrementing 2 at a time, right? So from 1 to 3 to 5, I'm skipping by 2s because the difference between each new iteration is going to be whatever was specified as the step. And then this is our last slide that we're going to have here. The for loop is going to be where we stop today. So a for loop is going to say for some value in your given range, then I want you to run these statements. Everything that's indented over will be the body of your loop. So we saw range just a second ago. And remember, there are multiple things that we could put inside of here. But just for loop is useful when you know how many times you want it to run. If I know for a fact that I want this to start at 5 and then go through all the numbers 0 through 4, right, because it's non-inclusive, then for I in range 5, print high. This is going to print out high 5 times, 0, 1, 2, 3, 4. And that's it.